皆さん、こんにちは。本日はお越しいただきありがとうございます。My name is Chris Horner. I'm an Android developer working on the design systems team at Cash App. And today I want to talk about building creative UIs with Compose. To do that together, we're going to analyze and build what I think is a fairly complicated UI. But before we do that, I want to give some context as to why I'm giving this talk in the first place. Here are some screenshots from my phone of apps that I use every single day. And something that strikes me about all of these different screenshots is just how similar all of the user interfaces are. Looking at these two in particular, Spotify and Pocket Casts, they're made by completely separate companies, and yet so much of their UI is remarkably similar, like down to the color of the Now Playing section. And my brain just really loves this. I don't have to think when I go to use one of these applications. I can just focus on playing music. But there is something else about these UIs that's kind of interesting, and it reminds me of something that a designer once said to me when asked about their job. They said, I arrange rectangles. They followed it up with, sometimes if I want to get fancy, I round the corners. Now, my designer friend was being tongue-in-cheek here, but I think, like all good jokes, there's actually an element of truth in this. When I look at these screenshots, I can see a lot of rectangles. The designers decided to get fancy and round the corners. But as UI developers and designers, we know the rectangles don't stop there. It's rectangles all the way down. And maybe this is okay. UI frameworks are built around rectangles, at least all the ones that I can think of. A lot of this starts with the device's screen. It itself is a rectangle. Our job as developers is often to come up with new and creative ways to arrange and nest rectangles. Design trends kind of steer into this as well. I want to talk about flat design for a second, and we're going to use the Fitbit app as an example here, a very classic flat design. Flat design is good for quite a few reasons. It's easy for a designer to put this together. You think about how quickly you could maybe whip this up in Figma. It's simple for a developer to build. I don't think we need our designer to export any assets from Figma for this. As a user using this, it's very low effort for me to read this. It should render very quickly. There's not a lot going on the screen. It's responsive as well. I can imagine how this would scale to different axes as it stretches. There's no textures we need to worry about stretching. And also, dark mode should just be one color palette swap away. Though I do want to throw a little bit of shade at Fitbit here for not supporting dark mode. There is something else about this UI, though. It's kind of boring. Boring is sometimes good, though. There's a bunch of things I do on my phone that I want to be boring. Making phone calls, contacting customer support, navigating somewhere, sending an email. I don't want to have to think about how I do any of these things. I just want to do them. But maybe we've gone too far. Maybe all of our apps shouldn't be this boring. And I can think of a time when not all of our apps were this boring. So I want to go back in time. Back to a time when UI is more experimental. Is everyone ready? We go back through time with the magic of Keynote. The year is 2009. iOS looks something like this. We take notes on actual notes. News comes from an actual newsstand. To record audio, we speak into an actual microphone. In 2009, HTC, rest in peace, announced the HTC Hero. I loved this UI so much. Like, look at the nice curve down the bottom. There's a lovely Web 2.0 glossiness to everything here. And I know it looks tacky now, but the way the water droplets hit the screen and the windscreen wiper comes in, I don't know, it's cool. In 2009, we see the decline of Winamp. Winamp was a desktop music player. It had this really funky, futuristic cassette player UI. One of the reasons why people liked it so much, though, is because you could skin it to make it look like anything you wanted. And people went nuts. They made all kinds of skins. Were all of these skins good? Absolutely not. But you have to give these people points for creativity. I would never have thought to make something like this. If you're as interested in this as I am, you can actually visit a Winamp skin museum at this site here, and people are still making skins today. But it's not old versions of Android or old music players that I want to talk about today. I want to talk about a kind of software that I think still have very interesting UIs today. They've never stopped being interesting. That's video games. The primary purpose of a video game is usually to entertain whoever is using it. They can take their time and be creative. There's one game in particular I want to talk about today. This game was released in Japan in 2016, developed by a P studio at Atlas. This is Persona 5, a game very famous for its creative UI. Let's have a look at some of the gameplay footage. This game is turn-based, so the player has time to kind of like look through this complicated UI and work out how it works. As you navigate through, menus kind of explode with these really interesting animations. Have a look at the way the options burst out of the player character, really blurring the line between 3D game world and 2D user interface. All of it here really augments this stylish theme. There's an obvious kind of influence of manga here, but maybe less obvious is the influence of 70s British punk magazines. Rebellion is a huge theme of this video game, and I can't think of a more appropriate kind of inspiration to draw from than punk rock. It's so creative. Like, who thinks to turn this into a UI? When you bring up the pause menu of the game, the main character of the game holds up his hand to the camera as if to block it from the paparazzi as he shows you the options. At this point, you might be wondering, though, what has this got to do with Compose and Android? Well, there's one UI that's found in the game when the characters are in class, and they use their phones to message each other. And this was unlike any messaging app I had ever seen before. There's so much style in how everything kind of moves in and is positioned, and with all of these interesting animations. And this made me wonder, how can we build this with Compose UI? I mean, this UI is actually breaking a lot of our rules. The main screen, it's not a rectangle. The chat profiles, they're not rectangles. The avatar's not a rectangle. How does this line work as it goes between all of these different messages? Each message, as it comes in, has so much going on. Let's look at it again in slow motion. There's so many individual elements we're going to need to animate here. And that's what I want to do for the rest of this talk. We're going to break free of material design and reimagine this as a real Android app. So let's start with something simple, the background. Here's a much simpler screenshot for us to work with. If we got given this as a spec from a designer, I don't think there's too much we'd need to do here to start. I'll make a box, and I'll give it the right color. As for this splatter effect that's around the sides, I think we can just use an image, put it inside the box. While we're putting images inside a box, we may as well take care of our IM logo at the same time. Nothing too interesting here, except for maybe the offset modifier. Offset is pretty handy when you're building more weird user interfaces because it runs after the layout pass. So it means that you can move something without it impacting all of the child elements in a container. All right, easy stuff out of the way. Let's move on to something more complicated. Text boxes. Text box has a really interesting shape. It's kind of like a trapezoid. And this is going to cause problems. You might think, well, could we just get an asset from our designer? Problem is, when we scale this down, you can see the sides of it sort of shrink in ways that don't look terribly great. And this made me wonder, well, I've drawn text boxes before in apps. Could I just use 9 patches? 9 patches, if you're not familiar with them, are a great way to sort of define parts of your image that you want to scale and stretch, and other parts you want to remain constant. This video sort of does a good job of describing why. Problem is, this isn't going to work. And loading in this next message, we can kind of see why. These blue boxes, they show you the area that we want to make available to the text. And if we draw a straight line between the two corners, you can see the angle of the line changes depending on how much text we've got inside the text box. And our 9 patch is really only going to work if we've got a straight edge. What is common, though, between all of these, between these two text boxes, is the amount of space between the text and the bounds of the text box. So if we know how much text we have to display and how big it should be, we should be able to calculate these coordinates. So let's do that. Compose UI has this really cool function called generic shape. And it's a great way to kind of build up something you want to draw at runtime. Specifically, what's great about it is this size parameter. So size is going to be passed to you at runtime. It means ahead of time, you don't need to know how big it's going to be. We're just going to adapt to whatever the size happens to be. To use this, we'll start by calling move_to. You can think of this as like moving a pencil to a particular coordinate on paper, but not actually putting it down yet on the paper. Calling line_to is like now we've put the pencil down on the paper and we're drawing a line. Here's where that size parameter is coming in handy. You can see no matter what size we might happen to be drawing, we're always going to go to the far edge. Next point, very similar, but now we're using both the width and the height. Move again, and then finally close out our shape. So we've got it. We've got a shape that we've drawn, but this code actually isn't quite done. We've defined all of these coordinates in pixels, and we want this to work on any size device. So we really want to define these in DP instead. Thankfully, this is very easy to fix. We'll just make this an extension function off of density itself. So when we're inside of a density scope, we can call the 2px function on top of DP, and it means we get to define the shape in DP, but draw it in pixels, sort of the perfect bridge. We can repeat the same process again for the inner text box. And if all of this is starting to sound tedious, there is actually a Figma plugin here that you can use where if you happen to have a vector shape defined in Figma, it's going to generate some compose code for you. It won't give you the size parameter like we just used, but it at least gives you like a starting point that you can use to then tweak some final numbers. For the text composable itself, I don't think there's too much we need to do here. That's kind of boring. What's interesting is when we go to draw these text boxes. We're going to use the draw behind modifier. Draw behind is great because it itself is already an extension function of density, well, it implements density. So we're inside of a density scope. It means we can directly instantiate our outer box and inner box. You might think, surely then we can just invoke draw shape and pass in our shapes with some colors. Not quite. This API doesn't exist. Instead, what exists is draw outline. Thankfully, it's very easy to turn a shape into an outline. Lastly, we'll define some padding to roughly match what the game has. We'll load up an emulator to see how we did, and it's pretty close. Kind of similar to the game, but actually written for Android. And this means we can do some interesting things, like enabling font scaling in our accessibility settings, and it's going to adapt perfectly to whatever the user's font scale is. Next step, the avatar. How are we going to draw this? Well, it's kind of similar to our text box, right? We've got a whole bunch of layers that we need to draw. But then there's also this foreground image that we need to draw over the top. And actually, we need to mask it to the background. You can kind of see how this bottom section here is going to need to be clipped. We can start by putting our text box inside of a row, and then we'll add the image as another child element in the row. I'll pull up the emulator again just so we can kind of see it running side by side with the screenshot. Not a bad start. Moving the image inside of the background, we can adopt the same strategy that we used before with the text box and just call draw outline. But with the mask, what are we going to do about that? Well, we can actually draw this in code if we want. And we'll use this lovely magenta here for debug purposes. But you can roughly see the bounds of what we want to use to kind of like clip the shape. What's great about this sort of shape API in Compose is you can use it for masks as well. So if we shift this down to the bottom, it means it's going to clip everything that's inside of the box itself, but not all of the other kind of like parent boxes. It's the last modifier in the chain. And we've got something that's getting closer. So we've got a text box and an avatar, but we haven't drawn the text box's stem yet. Let's address that now. And the reason why we haven't done that is because of how this thing animates. I want you to pay close attention to the left-hand side here. Watch how the stem stays very stationary, but everything else grows around it, and the lines kind of like come out very elegantly. Well, you might say, if it remains static, then could we just make it a separate child inside of our row? Not really, and that's because of how this thing draws. And so I'll kind of need to break this down a bit. We want to start with the white part of the stem, then the white box, then the black stem, then the black text box. And this order is very, very important. And it's maybe more obvious if I draw it with any other combination of draw commands. And we shrink it down a little bit to match what the animation is doing. You can see the stem really doesn't line up nicely with the other two. We've got some nasty artifacts without having everything line up perfectly. And so what that means is the stem has to be part of the text box when it comes time to drawing. If we want the text to overlap with the avatar, how can we do that with a row? Well, you might think maybe we could add an offset modifier to the text box to kind of shift it over a little bit to overlap with the avatar. Problem is that's going to leave a nasty gap on the right-hand side. And if I load in the next message, you can kind of see we really want to be able to take up all of the possible space we have available to us when it comes time to render the text. So we've got a custom layout here that we need to build, really. Especially when you consider if the message is short, we need to anchor the text to the bottom of the avatar. But if the message gets long, then we need to anchor it to the top of the avatar. So it's time for custom layouts. A quick refresher on how these things work. You typically have one content slot here where you put in all of the composables that you want to draw, and then another lambda here where you get measurables and constraints. Typically, the way this works is you iterate through all of your different measurables to get placeables. And then with a given width and height, you place each of these placeables wherever they need to go in the layout. But we're creating just this layout, not any kind of generic layout. And that means that we get to be far more specific if we want to. We can pass in just the avatar and the text box. These are the only two things we're ever going to need. What that means is we can use Kotlin's destructured declarations to really simplify how these measurables are dealt with in code. We get named measurables that we can work with. The avatar is pretty easy to place, or pretty easy to measure. We don't need any custom constraints. The text is more complicated because we need to work out how much the total width is available to us. So we take the total width of our whole layout, and then we subtract the avatar's width and then add back in a little bit to kind of get that overlap. With those constraints, we then have enough information to create a placeable from the measurable. With both children measured, it's pretty easy for us to calculate a width and a height to use. And then we'll start putting things down. The avatar, simple, top left. The text box is slightly more complicated because it depends on how tall it is, but thankfully I don't think the code is too complicated. And what it means is we now have a very specific layout that does this one thing that we want. Great. But what if we want to display these in some kind of list? It's starting to come together. It's looking like the Persona app. Worth noting for this, I decided we need to use a LazyColumn, and that's because we don't know how many messages we're going to have. We need some sort of container that's going to recycle as it scrolls. But if we're using a LazyColumn, how are we going to render the line behind all of this? This was definitely the most challenging part of the app to get right. Let's start by deconstructing the line's behavior. It starts by centering itself to the very first item in the list. And then it's going to zigzag left and right by some sort of random offset. And then it finally centers itself to the last item. It also kind of does this weird jump snap before it starts animating down to the final position. It's sort of this, it's easy to see in slow motion watching that left-hand side. So to get this right, we need to go back and kind of talk about data modeling for a second. For the avatar, we're just going to model this as an enum of sender. It has an image and color, everything it needs to draw. A message we can think of as being a combination of the sender and then the text of what was actually sent. We also need to store some line coordinates. And this is where things start to get tricky. By line coordinates, I'm referring to these 2 points on the side of the line here, left and right. And we're going to store these using Composer's offset type. And that's important, but I'll get to why in a second. We'll wrap all of this inside of something called entry. So this is sort of like the final, I guess, aggregate of all of the different things that we're going to need to draw. Where are we going to store this, though? Where does this come from? Is this going to be some sort of view model? Is one option. Or some kind of UI state. By UI state, I'm talking about things like scroll state, pager state, text field state. All of these things you've probably come across if you use Compose UI framework code. We can make our own as well. The view model is really good for displaying the current list of messages. You can kind of, or for storing the current list of messages. You can think of this as like the business logic, essentially. We want to put these entries inside of UI state because they contain pixel information. The view model has no business knowing anything about that. It also means it's a great place to store things like item animation progress. So you want to think about the flow of data through our application. We're going to go from like view model to UI state and then into LazyColumn. If you've ever used remember scroll state before, we can actually make a very, very similar API to it here, but this time we're going to return a transcript state instead. Worth noting, I'm keying off of the density here because if this happens to change for whatever reason, then all of our pixel calculations are totally wrong and we want to throw them away. Transcript state is going to act as the source of truth for all of our list of entries. So we're going to annotate this class with stable to pinky swear that if any of our public properties change, we're going to notify the current composition. And then we're using a state here to kind of drive that. So over time, our entries might look like this: 1, then 2, and then 3, and so on. But how are we going to calculate these line coordinates? We want to join to the center. I think this isn't so hard. The left we can kind of calculate by taking half the avatar's width and half of the line width that we want to use. Add our line width to that to get the second coordinate. Y is just half of the avatar's height. And then we can bundle them all inside of this line coordinates object with the left point and the right point. If we were to draw that from our previous entry, it would start to look like this. But what if we want to go left and right? Well, we could probably just look at the index of what message we're at and see if it's divisible by 2. If it is, we'll go one way. If it's not, we'll go the other. And we can multiply that by some amount, some random amount that we'll calculate, and that's going to push us in either direction when we multiply it by the direction. This means our new line is going to look something like this. And if we repeat it for each section, color it black, give it a drop shadow, it's starting to look like our final result. How do we put this in a LazyColumn, though? One thing we could do is look at how LazyColumn itself works. It already has a state that it remembers. We've got our own state that we've created to drive the entries. And we're passing these entries into the LazyColumn. Could we just make a new composable behind this and call it background line, and we'll pass it into the list state and whatever our current entries are? Should be enough for all the drawing information we need. Lazy list state also exposes this pretty neat property here, this visible items info. It has this one variable that seems perfect for us. The main axis offset of the item in pixels, it is relative to the start of the lazy list container. And that's going to give us the y coordinates of each one of our visible entries. And as the list scrolls, we should get new y coordinates. So the basic idea here is where we'll use a canvas, and then with all of that information we have, we should be able to draw between all of our different points, right? But I'm going to fast forward to what this looked like in the end when I pushed it to a device. It looks all right when it's still, but as we scroll, you can see it's not looking too great. It's not in sync at all with the speed that we're scrolling, and it's definitely not synchronized with Android's overscroll effect, which I really didn't want. So the reason why I'm talking about this, though, is it sort of demonstrates how many times you're going to need to have a go at this to get something this complicated right. Back to the drawing board. One of the big problems we have is each of our entries is going to be a different height. We don't know how tall each one of them is when it becomes time to drawing. Except each individual entry itself knows how tall it's going to be when it goes to render. And then the amount of space into the next avatar is always going to be a constant amount because we know that for the next entry in the list, its avatar is at 0, 0 of its entry. So we've got this overlap height we can use. And in Compose, children, their drawing commands aren't clipped to their bounds by default like they were in Views. And so that means we can cheat a little bit here. So if we were to draw this as the background of one of our entries, it would look like this. And then the next one, you can kind of see how it starts to piece everything together. Let's make that modifier. We'll call it draw connecting line. It takes in 2 entries. And this time we're going to use draw with cache. Draw with cache is great because it's going to let us do a bunch of calculations and then keep them in memory as long as the size of our component doesn't change. And that's great because we've got a bunch of calculations we want to do. We'll allocate a path and then we'll work out what all of our different points are going to be. And then we draw. This is actually very similar to the shape code that we had before, but this time we're using a path instead. So the only real difference you need to keep in mind here is we're using rewind, where we're caching that one path object and reusing it, because this gets called every single frame. We want this to be as fast as possible. While we're here, we may as well draw the shadow as well. And here I had to reach into some Android graphics code in order to make it work. But thankfully, there's this method, draw into canvas, that lets you go back and use some of the, I guess, more fundamental Android drawing commands. We can use this blur mask filter. Much better. It's starting to look like the actual app. It's scrolling in sync. It's in sync with the overscroll effect as well. It's everything I wanted. All right, last step. How are we going to do these animations? So our entry is already storing our line coordinates. We can store our animation data here too. We need to keep track of the line progress. So we're going to say this is a float from 0 to 1, depending on how far down this animation it is. The background and foreground of the avatar scale at different rates, so we need 2 separate properties. For our text box, the horizontal and vertical scale are different, and we need to worry about the alpha at the same time. To do this, we're going to use Compose UI's animatable. And I really like this type for 2 reasons. The first one is we get to specify an initial value. So our background actually starts at 60% scale. The second reason I like it is because we can call animate to, and this is a suspend function. So we're going to say, all right, the next step, I need you to animate to 1 over this duration. Of course, the type of this that it creates is animatable, but when we consume this code, we want to consume it as a compose state. Thankfully, there's this handy asState function that is going to mask the type for us. The reason I really like this coroutine-based API, though, is when we go to render the foreground, we can say start at 0, wait 160 milliseconds, jump to 80%, and then finish our animation. And these are all suspend functions, so we just kind of get to write them in line like this. What's our consuming code look like? Well, thankfully, we've done all the hard work inside of the state. When it comes time to draw, we can just pass it into the scale modifier. The foreground, however, is slightly more complicated. And one of the reasons why is because we need to scale up from this point here. So we're going to use a graphics layer instead. What's nice about this, though, is it gives us this transform origin where we can say, I want you to render from this point below the image. So we get that nice scale up effect. Lastly, we need to animate the line. Right now, our drawing code looks something like this. So we've got our final bottom left and bottom right points that we're drawing to. Instead, what if we updated this to draw to kind of a current bottom left and current bottom right? And so for this, we can use Compose UI's lerp function to linearly interpolate between 2 different points. So we pass in top left, and then we say, this is your current percentage, so this is from 0 to 1. And that's going to calculate a new point for you in 2D space based off of that fraction. What's interesting about this is it's returning this offset type. And you might be saying, well, this is bad. Aren't we allocating a new object every single frame as we interpolate between 2 points? What's really neat about offset is that it's a Kotlin value class. That means that at runtime, the 2 floating point values of x and y get packed into a single long. So you're only paying the penalty of using primitives instead, rather than actually allocating an object. But when you write your code, you get the convenience of using an object. All right, let's see how it looks. Pretty good. I made a couple of tweaks to the size of some of the elements to make it feel a bit more home on an actual Android phone, but I tried to be as close and true to the game as I could. We'll watch it again in slow motion to see how we did with the animations. We've got things kind of like having the nice bounce effect. We can see our line does that little jump before it animates down to its final position. I was pretty happy with how this came together. So what are the takeaways from this talk? Compose UI is just super cool. It lets you do all sorts of stuff to be really creative. I think the types like path and generic shape and offset having no runtime cost are just super cool. You can play with it and do really interesting things. Some UIs should absolutely be boring. I don't want every app to be as exciting as this one. But not every single app should be boring. Like, I think we've kind of lost some of the magic with all the consistency that we've gained. And so if there's anything you take away from this talk, it's maybe try and be a little bit more experimental sometimes, when it makes sense. And I think video games are a great source of inspiration. They've always been interesting. They continue to be interesting. They don't have the same restrictions as us, and that means that we can learn a lot from them. If you want, there's this lovely curated database, GameUIDatabase.com. The folks who maintain this do a brilliant job. It's very searchable. You can look through stuff, and you can find some amazing inspiration. Lastly, we went through a lot of code today, but we still actually didn't get to finish. We didn't cover how to draw the profile pictures, how to do the typing indicator, or how to draw any of these snowflake particles in the background that we saw in the video. And I don't want this talk to be a like, hey, yeah, you can go finish it, draw the rest of the owl type of thing. So all of the code from this presentation is online here at this GitHub link. You can also find these slides at this QR code. If you have any questions, please feel free to reach out on Mastodon, or I know Twitter is still very popular in Japan, so you can find me on Twitter here as well. But with that, thank you so much for coming to this presentation. Thank you very much to the interpreters doing the live interpretation, and to all the DroidKaigi staff for organizing such an amazing conference. Thank you.